Nearly a decade after it first landed on Mars, NASA's Curiosity rover is still making new discoveries and snapping stunning pictures, all while climbing up an extraterrestrial mountain. What's next for this Martian trailblazer and its ambitious successor, Perseverance, which more recently dropped in on the Red Planet? To talk Mars today, I'm really excited to welcome Abigail Freeman. She is the Deputy Project Scientist on NASA's Mars Curiosity Rover. Abigail, thanks so much for talking to us today.
Oh, thank you so much for having me. I'm excited to be here.
Could you tell us a little bit about where Curiosity is right now?
Yes, so Curiosity is continuing to climb Mount Sharp, which is this big mountain that's in the center of a crater named Gale Crater. And we started at the bottom of the mountain and have been slowly making our way up, reading the layers of the rocks as we go, which is giving us insight into, Mars's really ancient history.
I just love the idea that this rover is a little mountain climber at this point. And NASA had recently released a huge panorama that the rover took. It takes absolutely gorgeous photos. And what's the sort of altitude that it's at right now?
Yeah, it is so cool. We still have a really long way to go before we get to the top of Mount Sharp, and we're probably not going to get there during the mission. We never planned to make it all the way to the top. But even now, we're over 500 meters above where we landed, which is something like 1,600 feet. For the first several years of the mission, we've been going through layers that are filled with clay minerals that our rover data showed were put down when there was an ancient lake that once filled the crater. As we're climbing, we're starting to get a sense that the minerals are going to change. We're going to see fewer clays, and instead we're going to see a bunch more mineral called sulfate, which is basically a salt. And so we're really curious what this all means in terms of how the environments in the past changed, how the environments that put these rocks down changed.
What does Curiosity tell us about the past habitability of Mars?
The whole question about habitability on Mars is really what Curiosity was sent to answer. So we'll step back a bit and talk about the rovers that preceded Curiosity, Spirit and Opportunity. These rovers not only found evidence for liquid water, but multiple episodes where liquid water would have been available at multiple times in Mars's history. So with Curiosity, we wanted to go beyond that and say, okay, we know we have one ingredient. Do we have the other ingredients we need? So that includes things like a source of energy. That includes things like organic materials. What we found with Curiosity was, yes, there was liquid water at the site. We think this was water that would have been nice and drinkable. So, really kind of friendly for life chemistry. And then as we've climbed this mountain, we're seeing just continued evidence that the liquid water would have been there for a long time, probably millions, if not tens of millions of years. We also did discover that, yes, kind of the building blocks of life that are needed, these organic molecules, those were also present in the lake and preserved in the rocks. So Mars was habitable in the past.
Can Curiosity itself detect life, or has it shed light on anything in terms of whether Mars is inhabited or was inhabited?
It's an even bigger leap to go from, okay, was Mars habitable to was there life on Mars? Mm-hmm. And we can't really do that quite yet with our rovers.
It's really exciting, and it's cool too to just see how one mission kind of builds on the next. I wanted to talk in particular about this amazing entry, landing, and descent and landing sequence that Curiosity did for the first time. It was so nerve-wracking to watch. I can't even imagine, if you're on the team, doing this very daredevil maneuver for the first time, what that must have felt like. So could you kind of take us back to that day in 2012?
One of my clear memories from that night is just walking into the lab at like 10 at night to start to get ready for all of this, and running into one of the engineers who is the lead for the parachute. And he kind of made the comment, we never actually tested it at these supersonic speeds on Earth. It's hard, you can't really do that. So yeah, I hope it works. But it was definitely 7 minutes of terror was a great way to describe it. But yeah, once we got signal of landing, it was so amazing. And then what was even more incredible was we got the first image back kind of in that first landing sequence, we could see Mount Sharp right away. And it was just so exciting. And we printed off the pictures, huge, and tucked them in the hallway. And everybody stayed up till 6 a.m. kind of trying to count the cobbles on the ground and figure out where we landed. It was a lot of fun.
It always makes me really emotional to see the entire team, after so many years of effort, be able to sigh that relief and celebrate. What is the innovation in this sequence, and how does it help to have these more sophisticated robots land on Mars?
I mean, the really big point in the way we needed to use this totally crazy landing system was because Curiosity was so big. And the reason it needed to be so big was to have those instruments to make the measurements I was talking about earlier, understanding whether there were organic molecules. Also, some of the technology they included with this actually allows you to guide your entry into the Martian atmosphere a little bit better. Certainly help kind of pick your landing site rather than landing on these airbags and just bouncing and ending up wherever you end up. So a combination of the sky crane technology and then just advances in something called terrain relative navigation. It's enabling more science, both by giving us the ability to carry heavier payloads, but also by giving us the ability to land at more interesting places.
Yeah, and it certainly makes for quite a dramatic show as well. What would you say are some of the big breakthroughs that Curiosity has enabled?
One of the things that Curiosity has on board is a radiation detector. And one of the really cool things that we were able to measure is when Curiosity got close to these huge towering buttes, we actually saw a decrease in the amount of radiation that was reaching the rover because these rock formations were blocking the sky. This is something that was predicted to happen, but we now on the surface for the first time have quantified how much of an effect that can make. And that's really helpful in thinking ahead to, future astronauts, and maybe they can use natural rock formations and terrain on Mars to help with their radiation shielding.
And, speaking of pioneering missions, you were also the deputy project scientist on Opportunity, if I'm not mistaken. I believe it was like 2004, 2005. So it's quite a while ago that one landed.
Spirit and Opportunity were the first Mars rovers that I got to be involved with. And I was actually in high school when both of them landed. I always loved space and astronomy. I watched a lot of Star Trek growing up. But it was seeing that this was the potential to be a job, driving rovers on Mars. What? that is the coolest job ever. So the thought was, well, I hope I can work on a mission like this at some point in my career in the future. I never in my wildest dreams that I would be able to work on that same mission, 10, 12 years later. My favorite part of landing is the first images coming back. But when Opportunity sent back the first images, they looked like the terrain behind you. It's just this dark sand that went on for miles and miles. And it was so different from any of the images of the surface of Mars. And so that just totally hooked me into the field of planetary science and planetary geology.
I mean, amazing experience for a teenager to have, to be in that room. It really does seem like destiny, that you were meant to be there.
I'm pinch myself every day. It's such a dream.
I understand too that you kind of have visualized this, that the path of opportunity across Mars, you've done like a visualization of your own career. What inspired that?
Yeah, I wish I could take credit. But it was actually right after I was appointed to this new role, I met with the director of JPL at the time, Charles Alachi, and I was telling him my story and my association with the mission. And he said, what would be really cool? If you took the path that Opportunity has taken and label it with milestones in your life. So, high school graduation, college graduation, grad school graduation. And I thought it was a brilliant idea. It's really amazing to see, all of these huge changes in life events as they happened to me. Opportunity was still going. And
that kind of speaks to how we kind of form relationships with these robots. Like when Opportunity finally did end its mission, it was really sad. It was like a person. Could you just kind of speak to that, how the public and how scientists kind of get attached to these missions in a really personal way? And
I think, the biggest attachment comes from the engineering team, who a lot of them, this is their full-time job, just keeping the vehicles safe and operating on the surface of Mars. And, they come in every day and this is what they do and they focus on. And so having that end, it's kind of a big closing of a book, and you come in the next day and it's sort of, what do I do? Then I'll also add, it's very easy to feel very insular because this is what we think about every day, all day. But to see the reaction that came from the public and, the things that were posted on social media and just the press coverage and personal notes we got, artwork people made, it really, at least for me, made me feel so wonderful to know that something that is so special to me is also so special to so many people.
And certainly Opportunity had this amazing character of being just like never quitting and doing so much. Could you sum up some of the things that Spirit and Opportunity did discover during their missions on Mars?
The one sentence tweet that you might say is they were the first missions to actually show that there was liquid water on the surface of Mars. But these rovers definitively showed that. But because they were able to explore for so long, we were able to go way beyond that. And it wasn't just there was water, but we found different types of environments that water was present in, and also different times in the planet's history that water was present. And then Spirit on the other side of the planet, completely different setting, found, I think, this totally amazing discovery of this kind of volcanic system that was not only wet, but probably had kind of heated water moving around in it, in hot springs and volcanic fumaroles. And if we're thinking about habitable environments, man, that's a great place for life to live.
Amazing. They really are little workhorses. What's the sort of plan for its future? How long do you think that Curiosity will continue to operate?
Like any rover on Mars, today could be your last day. We never know. Our power supply should continue to produce enough energy for us to operate for many years to come. There's two other big features we see from orbit that we're going to get to explore soon. One of them is this big deposit of what looks like sandstone that's sitting on top of these lake rocks. It's much, much younger rock. And we think it formed in a very different time period when it was much drier and actually represents these big windblown dunes that were blowing across the planet. And then even sitting on top of those much younger sandstones, we see this amazing deposit. It's called Geddes Vallis Ridge. And one of our hypotheses is that this channel, Geddes Vallis, was actually carved by a lot of water very, very late in the history of Gale craters. And so it's going to, again, kind of continue to step us forward in time. And we're going to get to investigate these rocks.
That's so exciting. What excites you about the coming decades in terms of Mars research and even beyond?
There's so much to look forward to. So, of course, there's the big sample return, which is actually getting the samples that Perseverance has just started collecting and then bringing them back to Earth. Our orbital data has shown us, and it's been confirmed by the small few places we visited, just how diverse Mars is. One of the coolest things about Mars is how old its rocks are. On Earth, our oldest rocks are eroded away. They're recycled back because of plate tectonics. It's really hard to find places on the planet that have really old rocks. That's not a problem on Mars. No plate tectonics, no recycling. So Mars has a record of kind of the first billion years of its history still preserved. And we've never had a chance to explore that before. And I think by extension, kind of understanding just how Mars as a planet works and what governed its habitability through time, we're going to learn a lot more about rocky planets in general and how they evolved and what governs their habitability.
That's really cool to know that it's not just limited to that planet, that you can make all these kind of interesting extrapolations about exoplanets that we're finding elsewhere.
Mars is the only place in the solar system to go if you want to find out what planets are like right after they form. We don't have that record preserved anywhere else in our solar system.